So good afternoon everyone and welcome back to the class on your CIM Lab. Right, so if you remember we were dealing related to the CNC milling problems and we were left out with the program number 6 which we were supposed to do by using CAN cycle. So here this is the given blank what we need to do. So when you look at this diagram, what are the operations you need to do? Can anyone let me know? Which are the operations need to be done? How many tools are needed? Any guesses? So every time we are doing the milling operations, turning operations, you should be familiar with the tools and which operations we are supposed to do. Can anyone let me know?
Ma'am, milling and drilling, ma'am.
Yeah, milling and drilling. So we need to do end milling and we need to do the drilling. So to do the milling operation, we need end mill tool, and to do the drilling, we need the twist drilling tool. And twist drilling tool, along with that, we are using like finishing boring tool also, right? Suppose if you want to make a drill of around 25 diameter, so we use a twist drill of 24 point something, so that the remaining part will be finished out by using the boring tool. So we are supposed to use G81 and G76 for twist drill and the boring finishing part. Apart from that, we need an end mill tool to perform the milling operation for the given depth. And here in the question, it has been told that we are supposed to use a billet or the blank size of 350 into 250 into 30 is our depth, what we have to take. Okay, so and that they have constrained that you have to go with G81 and G76, right? So you are supposed to use both tools for getting the required hole drilled out. Apart from that, the regular end mill, right? End mill tool we need to use to determine the milling. So here you can see the dimensions. This is the cutout part which has to be made. From here, if you start, it will be in this way, then have a circular interpolation and again come back. So this will be the end mill tool operation, what we need to do it. And apart from that, we have 3 holes which have to be drilled out. So the outer circular interpolation has a radius of 75. So the inner one, the axis through which the 3 holes are drilled out is of around radius R30. So this is the part what we have to develop or to make. But to do this, you have to design a billet dimension. So that is of 350 into 250 into 30 So you need to put this design within an box, right? So that will help you for your getting the dimensions. So you'll just fix a blank of the known dimension as told in the question, right? So that the zero reference will be from this position x0, y0 and z0. So this is the part which has to be made on the given blank, right? So here we assume that this part what we have to create is equally distant from all the sides by 25 So this will be 25, 25 and 25 and 25 right? So then you will start up with your coordinates from this point. You will move from here till here, there, have a circular interpolation and again come back. So this is the path what we have to do. So then we will go for the drilling. So before going into the coordinates, basically, you have to start up with the program, right? So you know how to start up with the program. First, you have to give an program number, right? So you will put an percentage character. So after that, you have to give the program number. So since it is program number 6, we are giving it as O006. So then you know the normal syntax. You have to follow with the sequence number. So we are starting with N01 and then you have to specify which is the unit you are using, whether it is in metric or in any other units. Since we have to follow with metric, we give here G21. And then you have to be specific, like whether it is feet per minute, yeah, what. Since you need feet per minute, we are giving here G94. So then G90 is very much essential, whether you're going with absolute mode, yeah, incremental one. So that you should be aware enough. So kindly do type it as G90. So this one step is now over. So later, you need to see that after every operation, the tool has to come to its automatic zero return. automatic zero return into this position, right? So and hence we write it as G28, which stands for automatic zero return, wherein all the coordinates will lie at x0, y0 and z0. Okay, for that purpose it is very essential to write. So then the very next step is you need to assign the tool, right? So you have to go for writing M06 change of tool and assign the tool which has been needed. And when you look at the diagram, first we need to do a milling operation. For that we need an end mill tool. So we are selecting here T1 as an end mill tool. And later the tool what you have selected should be compensated, right? So you have to go for tool compensation, which is G43 for the offset number 1. So this offset number is assigned with the tool compensation so that the tool length is shortened as per the requirement with respect to the data which is available in the control memory, and hence this step will be common enough. After you do this, to make the machine run, you need to make the spindle on and provide the required speed. Along with that, you should make the coolant also on. So you will write M03, provide the spindle speed as 1500 and make the coolant on. So once this is done, you should bring the tool nearer to the position where you want to do the operation, right? So first, you cannot directly go to the position where you want to give the feed rate. So first you will drop the tool nearer to the reference automatic zero return. So it was x0, y0, z0. So it will be touching the blank actually. So in order to make the operation start, use the rapid traverse and slightly lift the tool above. So because you're providing Z10, if you provide Z minus 10, the tool goes in, right? So you provide Z10, X0, Y0. So it will be above the blank. So now the tool is ready to move to the position where you want to do the end mill, right? So to start up the end mill, see we need a linear interpolation and hence we are going here with G01. So now it's our duty to provide the coordinates so that the tool will be exactly to the position where the milling operation has to be done. So you need this position, right? So you have to think about the coordinates now. So all are equally placed 25 mm from all the four corners, right? So this is our positive X and this is our positive Y. This is positive Z. If you go Z inside, it is minus. So this you are aware about the coordinate system. So now this position, check out what will be the coordinate system, right? So it is away 25 mm in your horizontal direction. So X will be 25, wherein the Y from here, it has to come here. It is told that it is equally placed with 25 mm distance. So you have to add this 25 plus 50 mm. So the location of vertical height here is 50 mm to this point. So it is 25 plus 50. The Y coordinate will be 75 mm. So you will write it here as X25 and Y75. Along with that, you have to provide the feed rate for milling. So you are providing the feed rate value as 100. But this will not work until you provide the depth. And hence, for the end milling to start up in a linear way, we are supposed to give a depth, right? So here, if you go, then the depth value we are giving it as minus 10. So it goes to a depth of minus 10 mm. The given blank has a thickness of 30 mm. So be sure you won't give the depth more than 30 mm. At least 25% or 50% of the depth could be considered, not more than that. Okay, so Z you are giving it as minus 10. So once it is started with the end milling, you have to provide the location for the coordinate for the next point. So I told you in the previous class also, in CNC mill, we just give the coordinates which is varying. The constant variable, no need to assign. Here also it is x25, here also it is x25. So don't give the value for the coordinate for x, only give the coordinate value for which it has been changing. So here x was 25. So when it moves linearly, your milling operation, here also x will be the same coordinate value. So x is 25. No need to write this. Only thing, the y value has been changing. So it was 75 here. So now if it moves here, you have to add 50 more. So it will be 75 plus 50. Finally, y value will be 125. So if we go back here, so you will show the linear interpolation G01 with the varying value along the y-axis, which is 125. By 125, it is 70 plus 50. It provides you y 125. And hence you will get this value. And once it is here, next again it has to move, right? So when it is moving from this point to this, you can notice you have the change in both the x coordinate as well as y, because it is traversing in the horizontal distance to some value. So that distance is nothing but 75. Initially x was 25, it is moving in horizontal direction by a distance of 75 So it is 25 plus 75, the x coordinate will become 100. Also, the y value is also increased in the vertical direction. It was 125, so now it has moved by around 50 So it is 125 plus 50. So y value will become 175. So you will write here as, write the sequence number first, N10, and then the coordinate for x is 100 and the coordinate for y is 175. And hence now the tool has reached this position. So after this, now again it has to move linearly, right? So when it moves linearly, we can notice that the value of x changes in the horizontal direction because it is moving. But wherein the vertical height, y remains the same. So no need of providing the value of y here. If you just provide the coordinate for x, it is more than sufficient. So it was 100 here initially, and the distance from this point to this has been given in the question as 125. So you will add 100 plus 125. So it becomes x to 25. But y remains the same because it is at the same height. Y value remains the same. And hence you just provide the value which is varying. So sequence number N11. Then you type x as 225. So we have reached this point. So after this, you can notice you have a circular interpolation and not a linear one. And hence instead of G01, you have to go either for G02 or G03. It again depends whether it is clockwise or anti-clockwise. Here you can see that it is moving in clockwise direction, and hence we go with G02. So initially for this, we had x is equal to 100 and y is equal to 75. After that, yeah, at this position, it was x to 25. So now, in circular interpolation, it has to reach this point. Even though it moves this point, the location of x remains the same. X is the same, x to 25. Only thing, the value of y will come down drastically. So it was 175 here. This entire height is 150, 50, 50 and 50. So if you subtract 175 with 50, the remaining value will be nothing but here y25. So in the circular interpolation, you have to give the coordinate value for here. So x will remain the same 225, but y value has been changed. You will give it as y25, right? So y25, and then you have to give the radius for the circular interpolation. So this outer radius is given in the question as r75. You can notice it is r75, and hence you have to write here as r75 and then provide the feed rate. So feed rate, you are providing it as R70. So now the tool has moved a circular interpolation path from here to here. So the tool is here. So then it has to move again this part and come back to the place where it started. So both these are of linear interpolation. So now the tool is here. It has to do the milling operation from here to here. So you have to see what is the coordinate you have to write down, right? So again from G02, you have to go back to G01. So you will type G01. Then it is moving from this point to this. So x was 225. It is moving in the backward direction. So you have to subtract this distance basically. So it is x 225 minus of 125 So if you subtract x 225 with 125, you will get the value as x 100. but y value remains the same. It was y25 here. Since it is of same vertical height, here also y remains the same, which is 25. So you will just write down the value which has been changed. So the changed variable is only the x coordinate. So here you will write as G01 because it has moved in a linear interpolation, and then the value of x, which is 225 minus of 125, it becomes x 100. In this case, now the tool has reached this position. So it has to go back to the point where it started to cover the part of the milling operation which has been asked. So it has to go back to its position, and even this is a linearly movement. So you will again write G01. It has to go back to this position. You know the coordinate of this point already, which is x25 and y75. So you will write directly as G01, x25 and y75. So now the tool has come back to the position where it started the milling operation. So the entire milling operation now has been done using the end mill tool. So the path traveled will be from here till here, from here till here, then it moves in this way. It will have a circular interpolation, then it will come back to its position from where it started. So to go for the next operation, the tool has to be lifted above the blank, right? For that, you have to provide the value of z in a positive way. So then you will assign the value of z as a positive one. You can give either z3 or z5, whatever, so that the tool will come above the blank by 5 mm. So this operation is completed. So now to go for the next, you should make the spindle off. You should send the tool to its home position, change the tool, right? So the next step what you will do is you will stop the spindle. So you have to write M05 and then you have to make the coolant off. So you will write it as M09. Right? After every operation, what is the thumb rule you need to follow? You have to send the tool back to automatic zero return. And hence you will write it as G28, which is automatic zero return. Right? So you, instead of giving x0, y0, z0, you will provide z5 because it is safer to keep the tool above the blank. Anyhow, we have assigned z5 already. The same thing we are following here. So it will come back to the automatic zero return at this position, a little bit above the blank by 5 mm. Right? So now the tool is in automatic zero position so that you can change the tool for the second operation, which is nothing but the drilling one. So you have to go with the tool change. So you will write M06 and then you have to select the tool. So here we are selecting the tool number 2, which is the twist drill tool. So here the twist drill, I think we are going with a diameter of 24.75 mm twist drill tool. So the remaining part of 0.25 mm finishing will be done by the boring tool. So once you have selected the tool, the twist drill tool, so then you need to provide the length compensation. For that you have to write G43 and show the offset number. So it is H02. So you have selected the tool and you have provided the required compensation so that the variable length of the twist drill tool could be adjusted with the help of the controlled memory which is there in the database. So everything is done, set right. So now you can make the spindle on. So for that you have to write M03 and give the spindle speed as required, and don't forget to make the coolant on. Right? So now the system is ready to do the required operation. So to do on, you have to know the coordinates. Where are the holes and how you will move. Whether you are moving from here till here, or from here till here. It depends upon your flexibility or the way in which you are convenient in giving. So I have just started from here to traverse in this direction. Okay. So if we want to locate this position, you should know what is the coordinate of this. Here, you know, at this point, it is x225 and y25, right? But to make the twist drill, you have to move the twist drill tool at this location. So this x225 will remain the same. The coordinate remain the same. Only thing, the vertical height along the y-axis is increasing. So here it was y25. So this entire distance is given as 50. So the location of this center of the hole will be exactly half of it. So you can consider 25 plus 25. So this will be exactly 50. So y50, x 225 and y50 is the coordinate to bring the tool here to the location where drilling has to be done. Okay. So you have to provide the coordinate system for that. So x 225 and y50. If you give the depth, it will go within the given blank, and hence kindly do provide the value of z, a positive one, so that the tool will be exactly at this position but above the blank, not touching the blank. That shows the tool is ready to perform the drilling operation. So once that is clear enough, now you have to go with G81. So G81 will provide you to perform the required drilling operation. So we have studied the syntax already for G81. So if you want to remember it again, we had done with all the type of operations, deep drilling. So G73, G82, yeah, drilling cycle, right? So they have insisted for us to go with G81, and hence we are going with G81 drilling cycle. So in the CAN cycle, we have to go in. So where the format tells you have G81, which will be provided with the X and Y coordinate system, and Z stands for the hole depth, and R stands for the initial safe position for the drilling to start on, and what is the feed rate you will be giving, right? The same thing now we are supposed to give in our program. So yeah, so X and Y value as per the new version of the software, we have given it already. So the remaining part has to be given the depth, the initial safe position and the feed rate. So the depth we are going with 10 mm. So the drilling tool will go 10 mm depth within the blank for doing the drilling operation. So the safe position for the tool is nothing but R5, which is nothing but Z5. Initially you will keep it above the blank, then you will start the drilling operation with respect to the depth assigned. Okay, and then the feed rate y is 100, so we will do. So with this, a drilling of 10 mm will be done by using G81 twist drill, which is of diameter 24.75. So once this is completed, actually we need 25 mm diameter drilled hole, but since two tools are being asked to use, we will do only a rough twist drilling operation, and then the smooth finishing will be done by using the boring tool, right? So once this is done, the drilling is done, we have to move for the next position. So initially here the tool was, so then using the twist drill, the drilling was done. Then we have to move the tool to the next position. For that you need to give the coordinate system, right? So here it was 225, and now the tool is moving even in horizontal direction by a distance of 30, because the radius here is given from here till here it is 30. So here also it will be 30, here also it will be 30, here also it will be 30, here also it will be 30. So it was 225 plus 30 mm you will add. So it becomes x 255. So the coordinate of x changes from 225 to x 255. Okay. So this is about the x coordinate. And later the y value also. So what was the value of y initially? The y value here is given as 50 mm, right? So now from here again it is moving in vertical direction. So from this to this it was 50 mm. So in that we had considered only half the value, right? So which is 25. So this 25 was left out, and from here till here again half of 50. So you will be having one more 25. So 50 plus 50. So y value will be 100. So what you will give you, the value here as, so we were in the second coordinate for the drilling of the hole. So G00 you will use rapid traverse and directly you will shift the tool to the coordinate x255 and y100. So the tool will come to this position. Okay, so once the tool is in this position, since it is a cant cycle, again it will opt for the same depth of removal of the material. Depth will be of -10 and the safer position will be of R5 and the feed rate will be the same. The second hole will be drilled out, X255 and Y100. So second hole is drilled out. After that, so again you have to use the rapid traverse and move the tool from this position to this. So it was X255. So now it is coming back to the initial point where the X was initially. Right. So this value will be X225 only. Only thing, now the change in the Y value, right? So initially the Y here was 100. So now it has been shifted vertically above. If this is R30, this is also R30. If it moves above here, even this vertical distance will be 30 mm. So 100 plus 30, so it will be Y130. X will remain the same, only the Y value is been changing. So you will provide the Y value as 130 and X value, sorry, X is also changed. It was 255, it is coming back by 30 mm. So 255 minus 30, it will be X225. And Y is been added from 100 to plus 30, so it is Y130. And hence you will write the coordinate as, where may we, yeah, here, xn24, x225 and y130. So by this the third tool is also been drilled out for a depth of -10 mm, right, by using the twist drill tool. So now 3 drilling operations has been performed, but the complete finishing is not done. Why? In the question they have asked us to use the boring finishing tool also, G76. So that part is left out, right? So once the 3 holes are been drilled out, so you need to change the tool again. For that, we need to make the spindle off, right? So you will make the spindle off and you will make the tool coolant off. So once this is done, always remember you have to bring back the tool to the automatic zero return. So kindly write it as G28, which is automatic zero return, so that the tool will come back to the 000 plane. Z, for the safer side, we are providing 5 mm so that the tool will be not touching the blank. Okay, so you will write it as G28, X0, Y0 and Z5. So once the tool is back to the automatic zero return, so then you can change the tool. So you will write it as M06 and select the third tool as per the question. It is of bore finishing tool, right? So finishing bore tool, that is considered to be as T03 in our case. Okay, so after this, again the compensation for the boring tool has to be done. So we type G43 and offset number as 3. So we have selected the required tool. So for the operation to be started, it's necessary that you have to make the spindle on, provide the spindle speed and the coolant on. So here it is just a finishing operation what we are giving with respect to the boring tool, and hence it's better not to give a high spindle value. It is just 500 which has been assigned. So this will be done. So after you provide the spindle speed, again you have to locate the location where you want to start up with the boring operation. So the location of the coordinate of the hole will be the same. This one, this and this. So we have identified the coordinates for these 3 positions already. So one is X225 and Y50. The second hole is X255 and Y100. And the third hole is X225 and Y30. So the same coordinates you have to again type here for finishing operation by using boring tool, right? So you will start up with the first hole. It's the same coordinate X225 and Y50. So the tool will now again come to this position X225 and Y50, right? So for this, you will provide, but still the boring operation is not started. So to be on safer side, you will provide a value of z positive 5 so that the tool will be in the proper location but above the blank. So now the tool is set, the boring tool is set to do the finishing operation and get the required dimension of 25 mm, right? Required diameter of 25 mm for a depth of 10. And hence you will now provide the depth of cut. So you have to go with G76, which is the boring cycle, finishing boring cycle. So if you remember back to the syntax for G76, you will be having one quiz related to the G codes and M codes. Hopefully in the next class, be familiar with all the codes if you don't remember. So usually we do a boring cycle, which is a finishing boring cycle to get the required finishing for the hole which is already been drilled out, right? For that we use the boring cycle, which is G76. So you are aware about the format. It has X and Y, which provides a coordinate of X and Y for the hole position, and Z will stand for the depth of the hole. And what is the safe position for the tool to be? Okay, so that, and then what is the shift amount you need to give at the bottom of the hole? So this you can provide it, or else you can select the tool already as per the requirement. Okay, so we are selecting here the boring tool of 25 mm diameter, and for the twist drill tool we have selected 24.75. So remaining of 0.25 mm is the shift amount what we are providing it, which is nothing but the Q value. Okay, and the feed rate. So this has to be given. So as per that, so if we come back to our program G76, we have provided the coordinate already. So here you will provide the safe position for the tool, the depth of cut and the feed rate, right? So once this is done, the boring operation will be done for the first hole. So it has been finished smoothly for a diameter of 25 mm, which is drilled for a depth of 10 mm. So this is done, then it's only work to assign the coordinate of the second and the third hole for which the finishing has to be done, right? So you will write the you will write the coordinate for the second hole, which is nothing but x 255 and y 100. After you write that, right, kindly provide the coordinate for the third hole. So the third hole coordinate, as explained to you earlier, it is x 225 and y 130. So please do write all the coordinates. Since it is an CANT cycle, all the three operations for the boring will be done one after the other. So this shows the end of all the boring operations for the holes which was drilled out already using the twist drill tool, right? So once this is done, what is the next step? We have to make the spindle off and the coolant off. So you kindly write it as M09 and M05. The spindle gets off, the coolant gets off. And then after every operation, I'm stressing every time it has to come back to automatic zero return. So you kindly write G28, X0, Y0. Let the Z value will be above the blank and hence it will be Z5. So once it is Z5, the tool will be back to this position, little bit away from the blank. So now the program has ended, all the operations are completed, right? So now you can directly give M30, right? So this will end the operation and the machine will be stopped. So once this is done, just put the percentage character which shows the end of your program. So this is a simple program what you have to follow. If you understand the concept to any given design, you can easily write the program, right? Only thing you should be knowing which are the G codes and M codes properly you need to use and a proper coordinate system to write in. So this will end with our program number 6 related to our CNC milling operation. Hope the coordinate system and the programming part is clear with you guys. Any doubts related to this? Hello? I need a response. Hope the programming part is clear.
Yes, ma'am.
Okay. So now let me stop the PPT and just make the video on for this program number 6. Let me share my screen. So here if we go for milling, I think this is 6, yeah. Is my screen visible? Is it
Yes,
visible, guys? Okay,
yes.
fine. So if you click CNC Mill, double click, so this window gets open, right? So then you can go for open an existing part program and select the program which you have written already in the notepad, right? So you select and just press open, so the program gets displayed here. So once the program gets displayed, so this is the saving symbol. So if you click here, the program gets saved. So after that, you go and select the blank. So always the second step is you usually select the blank size. So if you go back to the question, you can see what is the blank size given, right? 350, 250, and the depth is of 30 mm. The blank thickness should be 30 mm. So whatever the depth you give should be lesser than 30 mm. If you give more than 30, so then you can it doesn't work out. And the minimum value what you provide for the coordinate, it should be 0 0. You should never assign a negative value for it. Okay, so that is a thing what you have to keep in mind. So as per the question also, you can change the blank size over here if required. So once everything is ready, you can press OK. So the blank gets displayed over here. So once the blank is displayed, the next step is first you will save the program after importing. So then you will set the blank size. After that, you have to select the machine, Fanuc, right? So you will go and select the machine, Fanuc here. So this is also done. So you will go for error check. You have to check if any error in the program which has been written. If any syntax error, it will show you below error status in red in color. So you can just cross check and see what is the wrong which has been happened. Okay, so once you have saved, you have checked, then you have to select the tool, right? So when you go for selection of the tool in the database, it might show you some tools which are there already, but don't proceed further as it is. Kindly remove all the tools which are been selected. You reselect as per your requirement, as per the question asked to you. Okay, so kindly remove all the tools which are configured already, and we'll add a new one. Usually end mill, what they have added already, see the end mill diameter is of 5 mm and the twist drill which has been purposefully selected to be as 24.75 mm because we need to do the finishing for 25 mm diameter by using the boring tool. So the diameter of the twist drill what you use should be comparatively lesser than that of the boring tool what you have to select. So you have to keep all these calculations in mind. Okay, so how you will vary. And usually for end milling, you won't have take the diameter more than 5 mm. So you erase the data which is there already and we will start adding it. So we will enter the tool number as 1. So it opens. Don't forget to change the unit. Okay, you have to go and change from, you have to change the unit to mm and then you have to select the end mill tool. So select the end mill tool here. It shows you the variables of diameter which are there. So in that you will go and select the diameter for the end milling as 5 mm, right? So you will select the tool 5 mm and then you can see the tool compensation length if any changes has to be done. Okay, so as per the data also you can retain. If any changes to be made, you can make. Okay, so usually we don't make any changes, so it will be as per the default. So now the end mill tool is selected. After this, two more tools are to be selected. One is our twist drill and the other one is the boring tool, right? So you will go and select the tool number as 2. Again, one more window gets open, right? So here change the unit into mm first, and then you come and check for twist drill. So if you click twist drill, you will get various diameters, right? So there are small variations in diameter of the twist drill, and you have a huge length of numbers. So just scroll down this down, you can see all the diameters of the twist drill which are available. Still down if you go, right, you can have for around 24.75 somewhere. Yeah, it is here. So you'll select the diameter of 24.75 mm twist drill. Right, so this gets edited. So now any variation in the length, if you need, you can do it, or you can retain the same thing. Just press OK. The second tool is added. Then go for adding the third tool. So the third tool here is our boring tool. So before that, don't forget to keep the unit in mm. Then come down and check for finishing boring tool. So bore tool you have here. In that, go for not rough bore. You have to go for finishing. So in bore finishing, please be careful about the diameter. Since the twist drill diameter we have taken less than 25 mm. Now for finishing operation, we are going with 25 mm bore finish. So select and press OK. So all the length will be the same. If any changes you want to, you can do it. Then press OK. So the third tool will get added on. So now you have made all the tools available for the operation. So once it is done, again you can check error check if you need, and then you go for the simulation, right? So you just click on the simulate button here. So first the end milling operation was done by using the end mill tool, right? After this, it was a diameter of 5 mm end mill tool, and later we are now going with the twist drilling tool. So the coordinates are fixed already. It will do the drilling for a depth of 10 mm, but however the overall depth of the blank is 30 mm. So be careful while giving the depth of the drilling hole. So it will make 3 holes drilled out, okay, using twist drill. So after that, the tool gets changed and the boring tool comes into picture. So this boring tool will do the finishing for the existing hole already. So it does the finishing operation. So once it is done, the tool comes back to automatic zero return and goes to home position. The same thing is again shown here for your understanding, the end milling and then the drilling of the holes using twist drill 1, 2 and 3. After that, again it goes to automatic zero return, change of tool, and boring tool comes and does the finishing operation for all the 3 holes, so that the holes which are drilled now will be exactly of 25 mm for a depth of 10 mm. So this is how the operation ends. Again the same thing is simulated. Any doubts in this? Hope the simulation part is clear. Kindly need the answer. Please let me know. Are you people there? Are you
Yes,
people
ma'am.
awake? You're sleeping. Slowly the response is. Hmm? right? So this is the program number 6 which has been completed. So now you should see that everything is there in your record with the completion totally, and in the next class we will be starting up with, let me share the screen. Capstone and Capsule. Okay, so here you won't be writing any program, so you will be showing the part drawing. So the program will be generated automatically. So you can cross check the program which has been generated based on the model what you are creating. So it is done for both the turning operation as well as the milling operation. So we use like CADM softwares which are readily available to do the design and models for all type of turning and milling operation. So once these models are ready, it will turn the part programs or it will generate the part programs. Okay. So this is how it is, like a reverse way of doing the operations what we were dealing until now, right? So this is nothing but capstone and capsule. So this we will be doing from the next class. So basically it has few steps which has to be followed. Okay, so this I will take in the next class. So now what my work for you people is, I will give you 10 minutes time. You have to prepare the G codes and M codes. I will be asking the questions. Why? Because it is a part of Viva voice marks which has to be assigned. For every program, you have 12 marks. You have some marks for the record, you have some mark for the program, as well as the viva. So for viva it is like 2 marks for each program. So I should know like how well you have understood the formats, G codes and M codes. So you will study the G codes and M codes for CNC mill and CNC turn for 10 minutes. So then I'll be asking you the codes. You people have to answer. So I will record your marks for 2, how much you will gain, right?
Ma'am, next class
We'll ask
we'll
in next
prepare
class,
and come.
ma'am.
How much time you need to prepare, Gautam
Yes, ma'am.
Krishna?
Next class.
What you will do now?
Ma'am, we'll finish records, ma'am.
How many programs are completed, Gautam Krishna?
Ma'am, milling first 2 programs, ma'am.
Okay. So remaining programs you're supposed to write. So if I tell by today I need all the programs completed, will you people will be submitting? You people will tell yes, but you will never turn up on the same day. That should not happen. Okay. So now no answer. You muted your mic. Where is the answer now, Mr. Gautam Krishna?
Yes, ma'am. Yes, ma'am.
Okay, not only yes. What about the others? The great Kanishka, are you there? Yeah, you went away somewhere.
Kanishka, you may reply.
It's not there for sure. Hello? Hello? Let me see when he will turn up. So based on that, he will get the attendance. Ishant, you're there?
Yes, ma'am. Yes, ma'am.
Shri Prasad?
Yes, ma'am. Yes, ma'am.
Anil Kumar?
Only Kanishka is not there, ma'am.
Yes, yes. Let me check with him. Chandan?
Ma'am, yes.
Ma'am, even I'm there.
Alok present.
Alok is there. Yeah, yeah. Dheeraj?
Yes, ma'am.
Abdul Kalik Pasha?
Yes, ma'am. I'm there, ma'am. Present, ma'am.
Yeah, very nice. We will take care of Kanishka a little bit later. So let him come back to the online.
I'm right
Ma'am,
here
he's
only,
there, ma'am.
ma'am.
He's
No,
there.
Kanishka, neither you attend the classes regularly for tribology, and in the lab you just keep it on and go somewhere. So from next
Ma'am,
class we
from that
should
time I was talking
post
only.
what you were talking, you tell me.
I'm saying I'm here only.
How many times I called your name?
Ma'am, we could hear him, ma'am.
I was replying only, no, ma'am.
Then I am deaf, is it? Deaf and dumb here.
No, ma'am. His mic was off, ma'am.
If his mic was off, how did you guys listen to his voice then?
We didn't listen, ma'am. Like, he's telling
Ma'am,
he
now when
was
you were
replying.
calling
Someone
Abdul's name, he said
see.
yes, ma'am.
Because someone told me that we heard he answering. So Okay, supporting your friend, that's everything fine, but it is essential that everyone be attentive, or else we need to force every student to make the webcam on and sit. So that is the only go. Right? So
What
now,
if students don't have webcam, ma'am?
yeah?
What if they don't have webcam?
How many of you are using laptop? How many of you are using mobile here?
Ma'am, I'm using desktop now.
I'm also using desktop.
Okay, okay. You might be having, even in desktop, there will be webcam, right?
For what,
Desktop, you
ma'am?
have to buy an
Very
additional
old
extra
model,
webcam, no, ma'am. It'll cost like 2,500 rupees.
Ma'am, for what, ma'am, webcam?
No, how we will come to know. Some students are studious, they'll be listening. Some, like Mr. Kanishka, they will make on and go away somewhere. How a teacher will notice whether he or she is there in the class?
Kanishka is also listening, ma'am, but I don't. Ma'am, he's a genuine boy, ma'am.
More
I know, I
studious.
Ma'am,
know.
who submits
I,
record and all, ma'am?
only submission of record will not show that you are very studious. You should attend the classes regularly. That all you say that you are somewhere in the native. I'm not still back to my home, so I'm not able to attend this. Blah 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 goes on always, right?
Goes
Throughout the
on always means
semester.
it's happening, so I'm telling no, ma'am.
But see that won't happen.
When
Okay.
exams are there, it won't happen, ma'am. I'll come back for exams.
Only for exams you do come back, is it?
No, why would he
Because
come
then we
back
have no
otherwise,
choice, no,
ma'am?
ma'am. We have to write the exams.
Mm, 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 mm. Fine. So now what you will do is you will write all the programs which has been pending at your end, and by 5:30, sorry, by 4:30, I need all the records back. And Viva questions, I will be posting you the Viva questions. You need to submit it after, like, I give a day or so that you can submit, so that I, along with the record marks, the Viva marks will be considered for your valuation purpose. Or else, if you're ready, I am free to give you 10-15 minutes. You can prepare and let me know the answers right away. Anything what you feel comfortable. What you will say either today or sometime later.
Sometime later.
Ma'am, next class.
1 week time you need for that.
Yes,
Ma'am, in
ma'am.
between we don't have, no, ma'am. If not, we
Mm,
can do
mm,
it.
mm, mm. Okay, then fine. I will assign you, like, you get ready with G codes and M codes of turning and milling both. Okay, and the syntax of all the type of operations. So let me see how well you have prepared. And all the students have to be present. Always the strength for the lab was good, and today it is only 13. May I know what is the reason for that? You
How
don't
will we know
have,
why other people bunk, ma'am?
it's your friends, your batchmates,
We don't talk to
right?
them that often.
Really, you don't talk to them that often.
Ma'am, we have a limited friend circle. Ma'am, Kanishka is our friend, ma'am.
They'll not reply, ma'am, usually.
No, every time there was a number of around 20 or 21, 19, but today it is only 13. So I'm asking. Just pass a message at least to your fellow mates,
Yes,
so
ma'am.
that they will attend the classes regularly. Take it seriously. Okay. You have the examination, both your theory as well as practicals. The dates, the drafts are already out from VTU. So I think some dates have been posted in your WhatsApp group also by HOD.
Yes, ma'am.
No, ma'am.
Yes, yes. See, draft timetable has been posted
Yes,
already
ma'am. Yes,
at
ma'am.
2 p.m. So kindly
Yes,
be
ma'am.
serious, attend the classes regularly. It's your subject, your marks, and you will gain a good marks if you study well. Okay.
Yes, ma'am. Thank you, ma'am.
Yes, ma'am.
Okay, thank you. Then no need of attendance. By 4:30, I need the pending programs to be uploaded in the Google Classroom. No reasons, nothing. Until 4:30, you have the lab session. Kindly use the time usefully and complete your records. And next week, you will be having the quiz, what you have to take on. So now let me take the attendance. Abdul Kalik Pasha.
Yes, ma'am. Present, ma'am.
Okay. Akhil KB? Akhil is absent. Hello, Kim?
Ma'am, present, but you already took my attendance, I guess.
When did I took your attendance? I'm taking now.
You called out my name sometime back.
Sometime back to see whether you people are there. Anil Kumar? Anil Kumar? Absent. Ankesh Aman? Ankesh? Absent. Gautam Krishna?
Yes, ma'am.
Balaji VR? Balaji is also absent. He was attending regularly. Balaji is there?
He's writing an exam today, ma'am.
What exam?
That IELTS, ma'am.
Okay, okay. Someone else called me. Abdul Khalik Pasha, you're there. Anil Kumar, where were you when I called?
Ma'am, network went off, ma'am. I just logged out.
Okay. Ankesh is not there, right? Gautam Krishna?
Yes, ma'am.
Okay, okay. Balaji VR? Absent. Basavraj?
Yes, ma'am.
Beldar Mohammed?
Yes, ma'am.
Chaitanya? Chaitanya? Absent. Chandan KN?
Present, ma'am.
Chetan Kumar?
Present, ma'am.
Okay. Dheeraj?
Yes, ma'am.
Ishant?
Present, ma'am.
Harshit? Harshit? He has a very shortage of attendance, like half out of 12 classes, 6 only he has attended. Inform him to call me. What is the reason? I need to know. Himanka? Himanka? Absent. Kanishka?
Yes, ma'am.
Okay. Kolepala Srinaga? Absent. Kunal Raj? Danush is not there. Mohammad Ayan? Mohammad Ayan is not there. Mohammad Junaid? Shri Prasad?
Present, ma'am.
Okay. So see that all of you are very good boys. Kindly do submit your records before 4:30. All the CNC milling operation programs have to be completed and to be uploaded in the Google Classroom by 4:30. So now it is 3 p.m. You have one
Yes,
and a
ma'am.
half hours.
Yes, ma'am. We'll ask Ishant,
Don't,
ma'am. He's the good boy.
only Ishant is good boy. What about the others?
Ma'am, okay, ma'am. Then I should get full marks and they should get 5 marks.
Yeah. So then, okay, I'll just grade only Ishant. So let me see about others then.
Ma'am, even I am there, ma'am.
See, I need the records of everyone by 4:30 without fail for all the milling operations which are pending from y'all by 4:30. Okay, no reasons that you have that, this, and all. Kindly do submit by 4:30. That's it. Fine.
Okay.
Fine, ma'am.
Okay
Yes,
then.
ma'am.
Take care.
Thank you.
Have a nice day. Good day. Bye bye.
Thank you, ma'am.
Thank you, ma'am. You too, ma'am.
Yeah.
Thank you, ma'am.
Yeah.
Thank you, ma'am.
Bye bye. Yeah. Bye bye.